In this video, we're going to take a look at circles and lengths of segments. First, we're going to start by looking at some properties. The first one is talking about chords intersecting inside of the circle, and then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So what that is saying is that this chunk times this chunk is equal to this chunk times this chunk. Next property is talking about two secant segments that are drawn from a point outside the circle, and the product of the lengths of one secant segment to an external segment equals the product of the lengths of the other secant segments and its external segments. So basically that whole mouthful is talking about the entire length of the segment, so C plus D, times the outside chunk is equal to the entire segment, A plus B, times the outside chunk. And we have one more property that's talking about a secant and a tangent, and it's basically the same situation that we had before. We're going to talk about the entire segment, which is A plus E, times the outside chunk, and that's equal to the entire segment, which happens to be C, times the outside chunk. So notice in the formula we have C squared, or C times C, equals E times A plus E. So let's try a few out. In this one I notice I have two chords intersecting inside a circle. So I have the product of the chunks of the segments have to be equal to each other. So I'm able to say that 3 times 9 is equal to 6 times A, or 27 is equal to 6A. I can divide both sides by 6, and I'm left with 4.5 for A. In this next problem, I see a secant and a tangent, and I'm trying to find the measure of BC, which is this piece right here. Now remember, I'm talking about the entire chunk, which in this case is 10 plus x, times the outside chunk, is equal to the entire chunk times the outside chunk. So I have 15 times 15, or 15 squared, is equal to 10 plus x times the outside chunk. I clean this up and I'm left with 225 is equal to, and I distribute here, 100 plus 10x. I can then subtract 100 on both sides, leaving me with 125 is equal to 10x. I divide both sides by 10, and I'm left with 12.5 for x. In this next problem, I'm trying to find the measure of EC, which is this piece here. I notice that I'm dealing with two tangents meeting at a point outside the circle, so I'm thinking about the length of the entire segment, so 28 in this case, 12 plus 16, times the outside chunk, is equal to the entire thing, y plus 20, times the outside chunk. So I set this up as 28 times 12 is equal to y plus 20 times y. If I clean this up, I'm left with 336 is equal to, and when I distribute, I have y squared plus 20y. Alright, I notice that I have that squared term here, and I have a y term, so this is a quadratic equation. So I'm going to start by subtracting 336 on both sides, which gets me to 0 equals y squared plus 20y minus 336. At this point I could try to factor, so I could look for factors of negative 336 that add up to positive 20, but there aren't any. So instead I'm going to have to use the quadratic formula, which says that our variable, and generally the quadratic formula is set up for x, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, my a, b, and c come from the coefficients in my problem. So my a is what's hanging in front of my y squared, so that's 1. My b is the 20, and my c is the negative 336. So I'm going to plug those things into my problem. So my y is equal to negative 20 plus or minus the square root of 20 squared minus 4 times 1 times negative 336 all over 2 times 1. I notice that I have two separate problems here because it's plus and minus. So at this point I'm going to split this up, one with the addition, one with the subtraction. So if I type in my calculator negative 20 plus the square root of 20 squared minus 4 times 1 times negative 336, I'm left with 21.76, and then I divide by 2, giving me 10.88 as my value for y. If I do negative 20 minus the square root of 20 squared minus 4 times 1 times 336, I'm left with negative 61.76. I then divide by 2, giving me negative 30.88. Well, if I look back at my original problem, I notice y is a side length, so this negative value does not work for me, so my final answer is that missing chunk, EC, is equal to 10.88. All right, moving on to the last problem. We're looking for the measure of x. I see a secant and a tangent, and again I'm thinking about the entire chunk, so x plus 3, times the outside stuff is equal to the entire chunk. Well, if I add these together and then combine like terms, that gives me 3x times the outside chunk. So I have x plus 3 times x plus 3 is equal to the entire thing times the outside chunk. I'm going to FOIL over here. So first terms I have x squared, outside I have 3x, inside I have 3x, and last I have 9. I distribute over here, and I have 6x squared minus 6x. I notice that I have these x terms, so I'll combine them. X squared plus 6x plus 9 is equal to 6x squared minus 6x. Again, like in the last problem, I have that squared term, so that's a hint that I'm dealing with a quadratic. So I'm going to move everything over to the right-hand side of my equation. So I'll subtract x squared on both sides. I'll subtract 6x, and I'll subtract 9. That gets me to 0 equals 5x squared minus 12x minus 9. I can choose to either use the quadratic formula, or just to show you a different method, I'm going to factor this guy. Since I have a leading 5 here, I'm going to have to take an alternate method to factor. So I'm going to multiply my 5 times negative 9, and that gives me negative 45. I'm looking for factors of negative 45 that add up to negative 12. Those factors are 3 and negative 15. So I'm going to replace that negative 12 with a positive 3x minus 15x. Okay, I replace that. That gives me 4 terms. So now I can group the first two together plus group the second two together. The first two have an x in common, so if I factor that out, I'm left with 5x plus 3. The second group has a negative 3 in common, so if I factor that out, I'm left with the 5x plus 3. I notice that both sets of parentheses include the 5x plus 3, so I can now factor this, and I can pull down the x minus 3 into one set of parentheses times 5x plus 3. I'm then left with too many algebra problems, and I have x minus 3 equals 0, so x equals 3. And I have 5x plus 3 equals 0. So if I subtract 3 on both sides, I'm left with 5x equals negative 3. Divide both sides by 5, and x equals negative 3/5. If I look at my original problem, if I plug in 3 for x, that's going to work in both spots, not giving me a negative side length. And even if I plug in a negative 3/5, it's going to still give me a valid side length. So in this case, I have two solutions. X equals 3 and x equals negative 3/5.